When two or more linear equations are considered at the same time, the equations are called a system of linear equations. The solution to a system of linear equations consists of the values for the variables that make all the equations in the system true. One way to solve a system of linear equations is to use the substitution method. Now, for the substitution method, we need one of the equations to be solved for one of the variables, and we need that variable to have a coefficient of 1. In this first system of equations, the second equation is solved for y, and y has a coefficient of 1. So we're going to substitute what y equals in that equation for y in the first equation. So I'll have 2x minus, but instead of y, I'll put what y is equal to. I'll put that 4x minus 2, and then I'll complete the equation. Now I'll distribute the negative to get rid of the parentheses. So I have 2x minus 4x plus 2 equals 6. Collecting like terms, I have negative 2x plus 2 equals 6. Subtract 2 from both sides. I have negative 2x equals 4, or x equals negative 2. To find y, I'll take the equation that's already set up to find y, and I'll replace x with that negative 2. So y equals 4 times negative 2 minus 2. So y equals negative 8 minus 2, or negative 10. So when x is negative 2 and y is negative 10, both of those equations will be true statements. So I'll write the answer as an ordered pair in parentheses, x first, comma, then y. Now for the second example, I see that the second equation is already solved for x, and that x has a coefficient of 1. So I'm going to replace what x is equal to for x into the first equation. So I have 3 instead of x. I'll put that negative 1/3 y plus 5, and I'll continue the equation, plus y equals 15. So I'll distribute that 3 to each term inside the parentheses. So I have 3 times negative 1/3 y, that's negative y, plus 3 times 5 is 15, plus y equals 15. Well, the y's cancel out. Negative y plus y is 0. So I have 15 equals 15. Well, that's always true. That happens when one equation is just a multiple of the other equation. So if we were to graph both of those equations, the result would be the same line. So the solution would be any point on that line. So there's an infinite number of solutions. We'd call these two equations dependent. Now in this third example, neither the x's, it's not solved for either x nor y. So I'll just pick an equation and solve it for either x or y. So let's take the first one. If I subtract x from both sides, I have y equals 4 minus x. So now I'll take what y is equal to and replace it for y in the other equation. So 2x minus y. So instead of y, I'll put what y is equal to. I'll put that 4 minus x and continue the equation. So I have 2x, now I'll distribute the negative. Negative 4 plus x equals negative 1. Collecting like terms, I have 3x minus 4 equals negative 1. I'll add 4 to both sides. I have 3x equals 3. So divide both sides by 3. I get x equal 1. Now to find y, I'll go back and get that equation that I solved for y. Y equals 4 minus x. And I'll replace the x with the 1 that we just found. So y equals 4 minus 1, so y equals 3. So my ordered pair would be x is 1, y is 3. So 1, comma, 3. That's the ordered pair. That's the solution to both equations. It makes both equations a true statement.